Hey, what's up, guys? Today let's look at the Lintcode problem number 596, minimum subtree. You were given a binary tree, and you need to find the subtree with the minimum sum, and we need to return the root of the subtree. So let's look at this example. You have this tree below, and you realize that the node 1 has the largest sum. Um, if you don't believe it, you can just calculate. All right, so let's see how we resolve this problem. And first thing is that we look for the keywords of this problem. We realize that it is a tree, and it is a binary tree. And tree, they all have the symmetric structures. So we probably will be thinking that we should use the divide and conquer this, techniques. Um, all right, and the second keyword is that minimum. So we need to find a minimum tree node with the minimum sum. So um, that means that we need to find a global, optimized solution. So that means that we have to traverse each tree node and calculate the sum and return and update our global variables and, in the end, just calculate our solutions. So basically, that's the two keywords. So let's see the code how we resolve this. And the find subtree is our entrance, and this is a tree node we're given. And first, we're gonna just declare a variable which is called a target node, which is what we have to calculate out, and we initialize it to be none. And the second is that we need to initialize the minimum sum, initialize it to be a max int. So this is the global variable. And then we're going to just call a helper function. This helper function actually is going to do all the calculations, is going to do all the heavy work to calculate the answer and assign the answers back to target node and the main sum. And in the end, we just return our target node, return the answer. So the core part is in the divide and conquer, is in this helper. Like we mentioned before, because this is binary tree, and we try to find the minimum sum, the node with the minimum sum. So we're going to use the divide and conquer way. And because divide and conquer, these techniques, it itself internally, they're using a recursive ways to do it. So this helper function is a recursive call. The first line in this function, we're going to just put the termination conditions there to make sure that we can always terminate our recursive call. So the condition is if the node is now, if the root is now, which is the return 0. What is this 0? Actually, this return value is the sum of this tree. Return the sum of this tree. If this tree is empty, which is return 0. All right, then we do the divide and conquer. So for the divide steps, we just calculate our left tree sum, and right tree sum by calling ourselves by passing a different parameters, which is our left subtree node and right subtree node. So this is done. We got the subtree answer. Then we calculate the current tree answer. Because we want to calculate the sum, so we just calculate it by left sum plus right sum plus current node, which is the root dot value, and in the end we just return the sum. So this is how we finish this helper function. But the most important thing is this: we have to do a comparison with the global variable, and we have to check that if the current sum we calculated out, if this guy is less than the global variable, which is self.mean sum. If this guy is smaller than global variable, that means we found a better one. So we're going to just update our global variable. So we update our mean sum to be the current calculated sum. We update our target node to be a root. And that's it. This is our helper function. This is the whole solution. So let's just submit. Looks great. Looks great. All the test cases passed. So thanks. That's today's algorithm. And if you like this video, then please subscribe. Bye.